To figure out the probability that a standard normal variable z falls between two values, we want to subtract the CDF of the higher value minus the CDF of the lower value. So let's take a look at what that would look like in a picture. Well, we know that the mean of this distribution is 0, and 2.72 is somewhere over here, and negative 0.31 is somewhere over here. When we find the CDF of 2.72, we're actually finding all this area to the left of 2.72. Now recall that the total area under the curve has to equal 1. Well, we don't want all the area to the left of 2.72. We want to find what's in between 2.72 and negative 0.31. So if we were to take this red area right here, everything to the left of negative 0.31, we took that away from the CDF of 2.72, we would be left with this yellow stuff that's in between right now. Let's take a look now at 4b. I want the probability that z is greater than negative 0.51. So let's shade that in. And that is all this area up here. We can't look that up in the table with our CDF, but what we could check out if we had the right information here is the CDF would give us the area to the left. But we can't look that up because it's a negative number and our table only has positive numbers. But we know by symmetry that the area to the left of negative 0.51 is equal to the area to the right of positive 0.51, and also the area to the right of negative 0.51 is equal to the area to the left of positive 0.51. Alright, so this blue area is the same size as that blue area. This pink area is the same size as that pink area. So now we can use our table to look up the CDF of positive 0.51, and you find that that's equal to 0.6950. So we know that the complement to that is 0.3050. Alright, so now 0.3050 is that area right there, and so we can use its complement. We know that 0.6950 is the area to the right of negative 0.51. If you'll notice, part C asks, what is the probability that z is less than positive 0.51? It's the same answer. It's this blue area right here. So 4C asks you to find the area between negative 0.51 and positive 0.51. Well, we know from the previous example that the area to the left of negative 0.51 is 0.3050, and that's also equal to the area to the right of positive 0.51. So we could get this as 0.3050, and this is 0.3050, and we know that the area under the curve is equal to 1, so we want the complement of that area. So this stuff in between negative 0.51 and 0.51 is equal to 1 minus this 0.3050 minus this 0.3050. So what you end up with there is 0.39. Notice you should have expected this number to be less than 0.68 because we know that 68% of the area falls in between negative 1 and 1. So the original copy had a second letter D. This is going to be 4E. The probability that z is equal to negative 1.14. Well, what we'd be looking for is the area of this right here, this line. Okay, so what we would want to do is take 1 minus the area to the left, minus the area to the right, and what we find out is that because this is a continuous variable, there's 0 chance of a particular value. Alright, we have absolutely 0 chance of this equaling exactly negative 1.14. Now, you might round from, let's say, negative 1.135 to negative 1.145, and that would be arranged. That would have a little bit on this side, a little bit on this side, and we could find this area because it would have both height and distance. However, if you think about this as area, when we try to find at any particular point, even the most common point would be around 0.
The width of that rectangle is still 0.
4F asks us to find the value of Z for which 6.18% of observations are greater than Z. So the probability that capital Z is greater than this Z that we're trying to find, lowercase z, is equal to 0.0618. So what we want to do is find some Z that leaves us an area in this upper tail greater than that value, and this area here is going to be 0.0618. Now we can't look that up in our table because our table gives us the CDF, but we know if 0.0618 is above Z, then due to the complement rule, all this area below Z to the left of that Z is going to be 1 minus 0.0618. So this is 0.9382. And what you want to do is look in your Z table and try to find 0.9382, and we find that Z equals 1.54. The CDF of Z equals 1.54 is 0.9382. That means that 93.82% of the time we would get a value less than 1.54 for Z, and 6.18% of the time we would get a value that's higher. Number 4G asks for a value of Z where we have 33.72% of observations less than Z. So we'd have 33.72% of observations less than some value Z. Okay, well, we know this is going to be a negative number because at 0 we have 50% of the Z's less than 0. So now what we can do is use symmetry to find out here at the opposite of this Z value we're trying to find, right? This is not going to mean negative, it's just going to mean the opposite of this Z value we're finding. We could end up with 33.72% above this Z. So what we can do is use the complement rule to find that f of this value is equal to 1 minus 0.3372, and that means that all of this yellow area right here would be 1 minus 0.3372. That equals 0.6628. So now let's look up in our table where to find 0.6628, and that leaves us this value up here equals 0.42. So we know that this value we were trying to find over here is the opposite of that, negative 0.42. And the last part of number 4 says we are looking for a Z for which we get 40.53% of the area between negative Z and Z. So what we're talking about is something like this. It's symmetric around 0, where we have 0.4053, and here's positive Z, and here's negative Z. We want to find out what is that number Z. What's nice about this is that we know that the area to the left of negative Z is equal to the area to the right of positive Z. So these red areas are the same, so each red area is going to equal half of the complement of the yellow area. So that means 0.29735 is up here, and 0.29735 is down here. So what we can do now is look at this Z. We can look that Z up in the table, and we can find the area to the left of that, and we would say that that is the CDF of Z if we just add up the yellow area and the leftmost red area. So f of Z is going to equal 0.4053 plus 0.29735. So that gives us 0.70265 to look up in the table. Now you may notice when you look in the table that that falls in between a couple values. Now we could probably just say that Z equals 0.535 since this falls between 0.53 and 0.54. It's maybe not exactly that number, but somewhere in between those two values. So the negative of Z would be negative 0.535.